Hey guys, and welcome back to the second video in this object and class tutorial series. In this video, we're going to be going over creating your own objects and your own classes and what that looks like in Python. So let's just go ahead and delete this code from the last video and start fresh. So if you guys remember in the last video, we talked all about objects, we talked about methods, and that's all cool. We kind of already understood a lot of that stuff. Like, we've used those methods, it makes sense how they work. But now, how do we create our own? And this is the whole goal of this tutorial series, to create your own classes and your own objects and add functionality to your program. So to create a new class, and this is going to be a new like data type, something like that, we'll talk about that in a second, you just simply type class and then whatever you want the name of your class to be. So in Python, they have int, string, list, whatever, okay? We're going to create a class and I'm just going to call it dog. Now, you probably have seen this example before if you do anything, with like classes or objects, because people like to use animals, but it's a really good example. So this is now creating a new class of dog. Now, what we have to do whenever we create a class is we have to add some methods into it. So remember, I talked about methods are things that you call on the actual class itself. So I'm just going to type define underscore underscore init underscore underscore, and we're going to talk about what this does in a second. And make sure you don't forget this self keyword. This object keyword you can leave out if you want. I just like to type it because I don't know, it's just a habit, right? Because we have class dog define init, and I'm going to make one more method and we're going to call it speak. Okay, and make sure you don't forget this self keyword. We're going to talk about what all this does in a second. Okay, pass, and in here I'm going to say pass. All right, so we've now just created our own class. It does not do anything, but we've created our own class. So what we actually do here is we're creating, well, a new class. It's equal to dog. It inherits from object. Don't worry about that. And this is what's known as the constructor method. Now, this underscore underscore init underscore underscore needs to be in most of your classes. Okay, so if you guys want anything to happen initially when you first create a class, you need to make this a init class. And what happens is when we create a new object, and the way we can do this is by doing something like, I don't know, Tim equals dog, like that. This method is automatically going to fire. It's automatically going to go off. We don't have to say Tim dot underscore underscore init underscore underscore. We don't have to do that. Whenever we create a new object of type dog, this is automatically going to happen. So, for example, if every time I created a new object of dog, I wanted to print out, nice, you made a dog, like this, then every time that we do this, so if we say like Fred equals dog as well, then it's going to print this to the screen. And I can prove this to you by simply running. Okay, so he says, nice, you made a dog. Nice, you made a dog. All right. We didn't have to call this init. It just automatically happened whenever we created this dog. So let's talk more about this init and what we can do with it. So in classes, there's things called attributes and methods. All right. Methods are anything that you create using define. Okay. And they look just like functions, except you have to call them using an object. And like we talked about in the last video, and attributes are kind of like variables that belong to a certain object. So to create a attribute, you need to use this self keyword, all right? What this self keyword actually stands for is it stands for the instance that you're calling. So Tim is known as an instance of type dog or of class dog. Now Fred is another instance of type dog. Now I'm just going to do this, and then hopefully you guys can understand how this kind of works, because it is somewhat difficult to explain. Okay, so now what we're saying is we've created this initialization, all right, and we have now that it takes a name, okay? So what that actually means is we have to now type a name into our initialization. So whenever we create a dog, we have to give it a name. So in here, I'm going to give it a name Tim, and in here, I'm going to give it a name Fred, all right? And don't worry if you guys are confused, I'm going to explain this all in depth in a second, okay? And I'm just going to do this so that we can actually see what our name is. Print, hi, I am, comma, self dot name. And we'll talk about what self does in a second, okay? Let's do Tim dot speak and Fred dot speak as well, okay? So let's print this. And it says, hi, I'm Tim, hi, I'm Fred. Okay, so how does this work? So in this initialization, this fires automatically when we create dog. Okay, so by calling this, we're automatically calling init. So if we put a parameter in init, so name, that means that we now have to pass a parameter when we create our dog. And just like a function, we can create multiple parameters. We can do like name, age, color, kind. We can do as many as we want, okay? And that works fine. Now, what does this self do? So this self actually represents the instance, right? So if I call dog equals Tim, or dog Tim, whatever, and I set that equal to Tim, well, Tim is what's being passed into this self parameter here. And notice how we have two parameters, but we only pass one thing. That's because self always needs to be here, except in like really specific cases that we're going to talk about later. So when we call self.name, we're saying that Tim.name is equal to whatever name we put in here. And that's the same thing with Fred, right? So when we call it on Fred, then we say, well, Fred.name is equal to Fred, all right? If we didn't do that and we said something like name equals name, if I tried to print self.name, that would just crash. It wouldn't work because we don't know which instance has what name. Okay, so this self means it kind of means like belongs to the instance that you're calling it on. I'm trying to explain this as good as I can because you really need to understand this. So I'm going to do another parameter here too. Okay, so self.age equals age. All right, and let's just print this out. And I am self.age years old. All right. Okay, so let's print this out and see what we get. I'm missing one. Age, sorry, I gotta put age in here. 55, 3, okay? So now if I print this, say, hi, I'm Tim and I'm 55 years old. Hi, I am Fred and I'm 3 years old, okay? So each of these are instances of class dog and they each have a name and an age, and you're able to call the speak method on them. Now what this speak method does is notice how when I call speak, it automatically takes self because it has to know what instance I'm calling it on. And that way it's able to access the name and the age. Now in here, you can actually change the name and the age. So I'm going to create a new method. I'm going to say change underscore age like this, okay? And notice how it takes self, no matter what, it automatically types it in for me. And here I'm going to do age, right? Now what I can do is I can say self.age is equal to age. And if I call, let's see here, Tim.change age, and I give it something like 5, now if I speak, you can see that we get, hi, I'm Tim and I'm 5 years old. And then we say, hi, I'm Fred and I am 3 years old. Now, obviously you guys can create as many methods as you want. You can call them whatever you want. Just make sure whenever you create them, they first of all have self, because we have to know what instance we're calling it on so that we can access those attributes, all right? And you can change these attributes however you like within those methods. Now I will show you what else you can do, okay? So say you wanted to access Tim's age and you didn't want to print out like, hi, I am all this. You didn't want to speak, you just want to know what his age is. Well, what you can actually do is you can simply print Tim.age. And now you can see, if I run the program, we get 5 down at the bottom. And you can do the same thing with name. So Tim.name, and it gives us Tim, like that. So we're actually able to access the attributes of our object from just simply calling whatever that attribute is. And in this case, it's name. So whenever you want something to be like public to the instance so like they can see it throughout all the methods, you need to do self dot and then whatever you want to call it. So I could say like self dot, I don't know, let's say li. It's going to stand for list. You could have a list of like 1, 3, 4. And now if I call tim.li, you can see we get 1, 3, 4. And obviously if I call fred.li, well, this is going to work as well. We get 1, 3, 4. Now the main benefit of classes is that you can create things, you can create multiple objects of a class. So if I wanted to store like the name, the age, and a list for 300 dog objects, if I wasn't using classes, what I would have to do is I'd have to do like dog1 name equals Tim, and then I'd have to do dog1 age equals 5, and then I'd do dog2 age equals Fred, and you'd have to continually keep doing that with a ton of variables, and obviously you don't want that. So these classes allow you to create infinite amount of objects of that type class and have all of these properties and attributes apply to them. Okay, so what else should we talk about here? Maybe creating new attributes. Okay, so attributes are anything that have this like self.name, self.age, self.li, whatever, and methods are with these define keys. Okay, so if I create a new one and I say define and add, what do you call it? Weight. Okay, I say add weight. I'm gonna give it a weight, and then we can say self.weight is equal to weight. And what this does now is it creates a new instance attribute that is going to be applied to this dog class. Now you see it's giving us an error here. It says instance attribute weight defined outside of init. That's because it wants us to define that inside of this initialization, but it's fine. You can actually do it out here. So now if I do tim dot add weight, I give it a weight of like 70, okay? And I'll print tim.weight like here. Let's see what we get. We get 70, okay? Now, what if I try to print fred.weight? Well, let's see what happens. We get Fred has no attribute weight, or dog object has no attribute weight. And that's because we have not yet added this by calling add weight on our instance Fred. Okay, so I think I'm going to cut the video off here. Hopefully you guys have a basic understanding of how classes worked. It is kind of difficult to explain it. If you guys have any questions, leave them down below because I feel like I might have butchered the explanation on some of it. Other than that, in the next video, we're going to go over, I think, inheritance and creating some more advanced methods and talking about how those work. Okay, so if you guys enjoyed, please make sure you leave a like and subscribe, and I'll see you again in the next one.